So the quiz on 8182 is going to cover the graphing of our sine, cosine, secant, cosecant, tangent, and cotangent. So my beautiful charts here are going to help you to memorize, hopefully, if you haven't already memorized them. The main thing to get you started with these charts is that at 0, the sine is at 0, but at 0, the cosine is 1. So that's a really essential part of how things are going to move along as we do them. So let's fill in the 5 x's. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay. So the sine starts at 0 and goes up to 1, back to 0, below the midline at -1, and back up at 0 again. So for a sine function, we hit the midline in 3 places. Here we go above it, here we go below it. Okay. Now the reason I have lumped cosecant and cotangent next to the sine is because every place that the sine hits that midline, or every place that the sine is 0, both the cosecant and the cotangent will have a vertical asymptote, because we're going to get 1 over 0, which is an undefined value. So let's put vertical asymptote at all of the places we see there. Now the cosecant's nice because the cosecant is just the reciprocal of the sine. So if I take the reciprocal of 1, I get 1. If I take the reciprocal of -1, I get -1. Now cotangent's a little different. Cotangent is sine over cosine. At pi over 2, the sine is 1, but the cosine is 0. So these are always going to be zeros for our cotangent. Now that leads us to the little chart about cotangent. Cotangent and tangent have periods of 1. All the other things have periods of 2 pi. So let's count from 0 to pi for our cotangent, and let's look what happens. So that's going to make us count by pi over 4s. So 1/4, 2/4, 3/4, 4/4. Now we already know that the cotangent has a vertical asymptote at 0, and we know it has a vertical asymptote at pi. We also know that pi over 2 is at 0. So the only other ones we need are pi over 4 and 3 pi over 4. Well, pi over 4 is that first quadrant, 45 degrees, square root of 2 over 2, square root of 2 over 2. It's always 1, and this one is -1. So that builds the sine, the cosecant, and the cotangent graphs very quickly and very nicely. Okay. So now let's, since we have that one, now let's go ahead and build everything that the cosine gives us. So the cosine starts at 1. Now let's put in our 5 x's. So those are just the quadrantals as we go from 0 to 2 pi. The cosine starts at 1, goes back to the middle, then goes below that midline to -1, back up to 0, and then at 1. These are all from the unit circle. You already have the unit circle memorized. These are just a way for us to organize that unit circle data. Now, the secant and the tangent both have cosine denominators. So every place that the cosine is 0, the secant and the tangent have a vertical asymptote. So let's put those on there. So every place that the cosine is 0, the secant and the tangent have vertical asymptotes. Now remember, the secant's the nice one. Every place that the cosine is 1, the secant is 1. Every place that the cosine is -1, the secant is -1. So we get these for free. Okay. Now let's go back and look at the cotangent. See how they were vertical asymptote 0, vertical asymptote 0. Same things happen here. All of these are zeros. So that doesn't give us a whole lot for the tangent. That's why we make up the chart to make it go between 0 and pi. So let's break down our tangent a little more thoroughly. Now we already have what happens at 0. we have what happens at pi over 2. We have what happens at pi. So we already know that this is 0, this is a vertical asymptote, and this is 0. Now let's think about pi over 4 and 3 pi over 4. Tangent and cotangent are reciprocals. If we know these are 1s, these are 1s. If these are negative 1s, these are negative 1s. If you do sine over cosine, square root of 2 over 2 divided by square root of 2 over 2, whatever you get it, that's a 1. And that's a negative 1. So you have to know those. If you don't know those, there's no way to graph these functions. And this all comes from what we know about our unit circle. So please, please, please make sure that you know these charts. I'm not going to have you give them to me precisely like this. I will show you what you're going to see more on the quiz as we go through the actual review. Okay, so please make sure you have those copied down. Make sure you study those tonight because our quiz is tomorrow. Okay. Now this review is definitely, if not maybe, the last grade for the 9 weeks. The quiz itself, it depends on if everybody finishes it or not, if it's going to be included on this one 9 weeks, but it might be the first grade of the new 9 weeks. I'll let you know. Okay. Okay, so now that we kind of have that, that's something you need to memorize. Let's look at what you're going to be asked for on the quiz itself. You're going to be asked to graph 3 of the parent functions that have not changed in any way, shape, or form. Okay, so initially I'm going to have you do sine, cotangent, and cosecant. On the quiz, then expect maybe the cosine, the secant, and the tangent. Just a little hint there. But anyway, so let's draw these 3 parent functions. So remember, the sine starts at 0. So let's fill this in. And then goes to 1, back at 0, negative 1, and 0. And so all you want to do let's get our graph paper ready. And once we get our graph paper ready, now we are ready to go. At 0, we were at 0. At pi over 2, we are at 1. At pi, we're back at 0. That's our first bump. What's great about the first 3 points of a sine function should always give you a bump. The second 2 points will finish off the wave. Now, if you stop there, you are going to get some points deducted. A sine function does not just go up once and down once and then it's done. A sine function continues periodically forever and ever to the left and forever and ever to the right. So please follow the pattern. Label how you count it. You might have counted a little differently than I did, so I have no way of knowing if your graph is correct unless you label stuff. So please fill up your graph paper. So that is how you graph a sine function. Now remember, cotangent, the period of a cotangent is pi. It is the only one where we go from 0 to pi. So when you build your graph paper for the cotangent, go from 0 to pi. Now remember, every place that the sine is 0, the cotangent, because it's cosine over sine, it will have a vertical asymptote. So go back up to the chart here. At 0, I'm going to have a vertical asymptote. And at pi, I'm going to have a vertical asymptote. Okay, so I know that we have a beginning and an ending on a vertical asymptote for a cotangent. You can also use pi over 2 as a helpful guide as to what happens. Remember, if you only do this chart, the cotangent and tangent, smack dab in the middle of every vertical asymptote is a 0. And so that's why this one's a 0. The ones that are weird are pi over 4 and 3 pi over 4. That's 1, that's -1. And it's just because of the quadrant we are in. So you might have to put your graph paper a little differently. So let's make this a pi and this a 2 pi. Just so it fills it up a little better. Now, if you decided to count a little differently, as long as you show me that, I'm good to go. So the first thing I want you to put on for a cotangent or tangent is your vertical asymptotes. So we have a vertical asymptote at 0, and then at pi. Now vertical asymptotes are equally spaced in both our secant, cosecant, tangent, and cotangent. So that means we get one here, we get one here, we get one here. Okay. The zeros are smack dab in the middle, so put it smack dab in. Now, if you have some type of shift in the graph, some type of midline shift, vertical shift, that point goes with it. So that's pi over 2. Now, if we count by force, that's pi over 4. That's 3 pi over 4. So we can mark all those little halfway points as well, just so we have a good guide. At pi over 4, we're at that square root of 2 over 2, square root of 2 over 2. That's why we get 1 here. But 3/4, or 3 pi over 4, is in our second quadrant. Both the tangent and cotangent are negative there. That's why we get a -1 right here. So we're going up to the left and down on the right. Now remember, a tangent does the opposite of that. A tangent goes down on the left and up on the right. So put those points on. Fill up your graph paper. So that's how you graph the cotangent. Now you're going to have one that is going to be a reciprocal function. And in this case, I'm going to use a sine and a cosecant to guide me. So expect these front three to kind of all match and go together. So we're still going to go from 0 to 2 pi on a cosecant. And just remember that wherever our sine is 0, our cosecant has a vertical asymptote. So we get 3 vertical asymptotes there. The reciprocal of 1 is 1. That's why pi over 2 is 1. But 3 pi over 2, the reciprocal of -1 is -1. So we have an up bump and a down bump. And that's what should happen for a secant and a cosecant. One of them should be +1 going up. One of them should be -1 going down. So let's set up our graph paper like the cotangent right above it, because the tangent, I'm sorry, the cotangent and the cosecant have vertical asymptotes at the same spot. So then we can use that as our guide. So let's make this pi and 2 pi. Let's make this negative pi and negative 2 pi. And let's put our vertical asymptotes on at 0 and at pi and at 2 pi. So then we also have them equally spaced. So a cotangent and a cosecant have vertical asymptotes at the exact same location. A secant and a tangent have vertical asymptotes in the same exact location. But for a cosecant at pi over 2, which is right here, we are up at 1. If we're above the midline, that is our parabola-like thing going up. At 3/2, which is right here, 3 pi over 2, we're at negative 1. That's a parabola-like thing going down. So if you end up above the midline, that is your parabola-like thing going up. And then just continue the pattern. So this one was next to an up, so it has to go down. And this one was next to a down, so it's got to go up. So guess what I'm going to give you on the quiz? I'm going to give you a cosine, a tangent, and a secant, because those three go together. So I've given you here as a review sine, cotangent, and cosecant. On the quiz, I'm going to give you the plain old parent, cosine, tangent, and secant.
Can you zoom back in on the left graph?
So make sure you have your graphs right. Make sure you can graph the original parent on the quiz. It's going to be the three opposites. It's going to be the cosine, the tangent, and then the secant. And make sure you label your graph paper so I know how you have counted. Okay, so make sure you label your graph paper so I know how you have counted, because you might count a little differently than I did, and that's okay. If you label it, then I'll know. Now, that's going to be the front of your quiz. The back of your quiz, we are going to take the opposite. So here I did a sine, and you will notice that I have messed up a cosine. So on the quiz tomorrow, I'm going to mess up a sine, but it doesn't matter. Okay. So let's make a little chart over on the side for what a cosine is doing. Okay, let's make up a little chart for what a cosine is doing. Cosine starts at 1, goes to 0, then at negative 1, then back at 0, and then at 1. Remember, for a cosine starts at 1, these two match, and that one is your bottom bump. Okay. And then you're going to have to answer the questions about this graph. Remember, our amplitude comes from that number right there. The period is 2 pi. If you set the x term equal to 2 pi and have to do any sort of solving, then you will get a change in the period. Otherwise, it's 2 pi. The phase shift, remember, you're going to set your parenthesis equal to 0. That is your phase shift and your start. So our start is at negative pi. Put that on your graph or on your table. The end, we're going to set equal to 2 pi. And so if we subtract a pi from both sides, our ending is at pi. Then we can fill out the x's. Remember, we're just cutting those in half and then cutting them in half again. Halfway between negative pi and positive pi is 0. Halfway between each of those is a half of a pi, one in the negative direction and one in the positive direction. The vertical shift is the number you see there, or you could write down 1. The midline is at y equals negative 1. Now, we use the chart that we've seen on the left there for the cosine, 1, 0, negative 1, 0, 1. To find the new y's, remember the new y's, it's just going to be 2 times the old minus 1. 2 times the old minus 1. 2 times the old minus 1. So that's why you have those, the old ones sitting there. 2 times 1 is 2, minus 1 is 1. 2 times 0 is 0, minus 1 is negative 1. 2 times negative 1 is negative 2, minus 1 is negative 3. And then we already did that math, so you can just fill those in. So let's fill in our graph paper. We need to go negative pi to positive pi. Okay, so we have our graph paper kind of filled in. So let's go ahead and graph our cosine graph. Now our cosine graph has been stretched, but it hasn't been flipped. Because it has a midline change, let's put our midline on at negative 1. Okay. Now we're ready to go. At negative pi, we are at 1. At negative 1/2 of a pi, we are at negative 1 back on the midline. That's always a half a bump we get for a cosine. At 0, we're at negative 3. At pi over 2, we're back in the midline. So that's where we get a full bump happens in the middle. And then at pi, we're back at 1 again, so we got a half a bump. So when I graph a cosine, the first thing I do is I count equally spacing, and then I come back down on both sides, or up if I'm flipped. So that's how I kind of make a weird M if I'm going to draw a cosine. And then once we have that spacing, then let's fill up our graph paper. So this would be down here, back to the middle. It should be equally spaced. Down here, back to the middle, equally spaced. Now we're going to come up to the top, back to the middle, equally spaced. Up, back to the middle, equally spaced. Down, and down. So that's your cosine graph. Now, our next two graphs are going to be built from that graph. These same exact transformations occurred, so let's use that to help us. So do you see how, look at my transformations. Same transformations, okay? So we're going to count each of these exactly like we did for the top ones. So this is pi, 2 pi, 3 pi, and I'll put my halfways. So I'm going to count my graph paper exactly the same. Now here's what's different about a tangent. The only line that changes for a tangent is this line right here. Okay? The amplitude's still 2. The period this time, though, is half of that. The phase shift, same. Vertical shift, same. Midline, same. Nothing changes. Let's put what the parent does. For a tangent, the tangent of 0 is 0. Pi over 4 is 1. Vertical asymptote, -1, 0. Every place that the up above graph hits the midline, you'll see it's at the halfway points, the pi over 2's. We have a vertical asymptote. So what I think you should do is just take those points, those halfway points, and put on your vertical asymptotes first. So there's a vertical asymptote here. There's vertical asymptotes, very close together. Okay. So the starting place would be a negative pi, but wherever the halfway point is, those 3 points right there finish out one of your tangent curves. So it actually ends at 0. The middle is a -1/2. And then these are the force. And what do we know? Every place that we hit the midline, remember, that would be this place and this place. See the pi over 2's? So the second spot and the second spot and the fourth spot. So the pi over 2 spot, this spot, see there's a vertical asymptote. So in this chart, the third spot is a vertical asymptote. And that's what we saw right here. See right here? There's your vertical asymptote that matches. So it's going to go 0 minus 1. Remember, you're old. So it's 2 times the old minus 1. 2 times 0 is 0 minus 1 is -1. So this one's -1. And then 2 times 1 is 2 minus 1 is 1. And then 2 times -1 is -2 minus 1 is -3. Okay, so let's put our midline on. And I'll zoom in so you can see it a little better. And then it just goes from, put your middle ones on. Because in the middle, tangents and cotangents hit the middle line. Smack dab in the middle, between the vertical asymptotes, we always hit the middle line. The amplitude is 2, the stretch is 2. So instead of going up 1, it goes up 2. So we have a point here, and we have a point 1 here. Stretch up 2, stretch down 2, stretch up 2, and I don't care from here if you just kind of guesstimate where that's at. Stretch up 2, stretch down 2, stretch up 2, stretch down 2. So if you compare it with our sine graph up above, every place that we hit the middle, we have an asymptote. Every place we have an up bump or a down bump, our tangent hits the middle. And then it has an up stretch of 2, down stretch of 2, up stretch of 2, down stretch of 2. Yes. Okay. So there's our tangent graph. I think the easier one for us to graph is going to be the secant down below, which we'll take care of in a minute. Because what's really great about our secant is we can build everything exactly from the cosine. So the hardest one tomorrow for you on the quiz will be a cotangent in this spot. Okay, so we've got our cosine. We got our cosine, and we know that we get to keep everything from the cosine. This is 2, negative pi, negative 1. Wait a second, I didn't write that right. Let's start over. 2 pi, I forgot the 2 pi. Negative pi, negative 1, y equals negative 1. Nothing changes. Secants and cosecants, or secants and cosines are reciprocals. Tomorrow you'll have a sine and a cosecant. You can use these exact values here. So just copy those down. The y's, be a little more careful. Just look back at your original. Every place that we have a 0, the secant would have a vertical asymptote. So let's put those on. That's a vertical asymptote. That's a vertical asymptote. So let's look back at our cosine. The flip of 1 is 1. The flip of 0 gives me a vertical asymptote. The flip of negative 1 is negative 1. The flip of 0 gives me a vertical asymptote. The flip of 1 is 1. So just build this by looking at that. This gives me that. This gives, or everything is linked. Now let's do our old. This is going to be 2 times the old minus 1. You'll see we've done that every time. 2 times 1 is 2, minus 1 is 1. 2 times 0 is 0. Is it a 0? No. 2 times negative 1. 2 times negative 1 is negative 2 minus 1 is negative 3. And then 2 times 1 is 1 minus 1 is 1. Lots of 1s there. Put on your midline at negative 1. I just kind of cut things in half here. Okay, let's put on our midline. Put on our vertical asymptotes. Compare the vertical asymptotes right above it. These vertical asymptotes and these vertical asymptotes should match because they each have that, in this case, a cosine in our denominator. On the quiz, I'll flip it. It'll be the sines, but they still should match up. So then put on all your asymptotes. Now, for a secant or a cosecant graph, Between the vertical asymptotes, we're not on the midline. We either up above parabola-like thing, up down below parabola-like thing, up above parabola-like thing, down below. Where are they at? Well, these are the ones, so they're up above. So let's figure that out. At negative pi, we're up above. We are at 1. So that's above the midline. That's a parabola-like thing going up. At 0, we're down at negative 3. That's below the midline. That's a parabola going down. Now, as soon as you get those, now we know how all the other ones go. This one's going up. Now we have a down. This one's going up. Now we have a down. This one's a down. This one's an up. This one's a down. Everything should be equally spaced, or you did it wrong. So that is what your quiz is going to be like. So let me just repeat. I'm going to flip-flop them. Initially, we saw a sine, a tangent, and a sine, a cotangent, and a cosecant on the front, a cosine, a secant, and a tangent on the back. Those will flip-flop, but nothing else about the setup is going to flip-flop. So please study tonight. Make sure you know this. Make sure you have that, okay? And that's what the quiz is going to be like.